G'day folks, Murry. Just thought I'd talk about terraforming planets and what's been going on, and I'll chuck another an idea into the universe because I think it's probably a bit more efficient and has a far longer term benefit to us. Now, when I look at a lot of the studies and scientists trying to come up with solving the problems on Mars, there's two really big aspects of Mars that you just can't get past, and so you need a lot of really complex science to try and figure it out and get life up there. And to be honest, it's already at one stage in its life, it's already been a hot ball of snot, and with an atmosphere and stuff like that. But it was too small in mass to be able to hold its atmosphere for life. And not only that, it's 1.5 times the distance of the Earth. So its sunlight's at least half as much. And that's for photosynthesis. So, I mean, I've been looking at a few of what the scientists have been offering, and they're not very practical whatsoever in terms of, they will probably do as they mention they'll do, but in terms of trying to turn the planet into a self-sustaining system, well, it's not going to happen because we get back to it's just too small a mass and too far away from the sun. And the sun's not getting any brighter. Well, it does, it has its cycles, but it's a big ball of stuff, and it's losing energy more than it's gaining. That's a simple, basic, end of story. You can't argue with that. While it's shining, it's losing light and an awful lot of heat energy, a lot of radiation energy that becomes heat down here. Now, that's 2 minutes already, so I'll just get straight into it. I'm just going to jump in the deep end and say, look, what we need to do is swap Earth for Venus. And by that, if you can imagine, you change the battery in your car or in your phone or in your drills, you're just swapping it out, putting the other one on charge. That's what we need to be doing with the Earth and Venus. Now, I know it's a huge Hollywood kind of scenario, and a lot of people won't like it at first, but by the time you digest it, and that could take a day or a week or 5 minutes, maybe a year or 10 years, doesn't matter. You'll come to the realization that it's the most efficient process, cost effective, and comes out with a long-term solution where basically we end up with another Earth. Now, our Earth has a surface chemistry that is going to be, it's in a process of entropy, whether it's the carbon cycle of life and the carbon that gets trapped. It continually gets trapped for as long as the plate tectonics keep trapping it forever, and it just takes that out of the system. That we've been digging it up and burning it. Boy, that's given us another lease on life. That's really good. And I know a lot of climate scientists, whatnot, will go, oh no, that's a dangerous thing. It may be, but you know what? Plants need it to eat, and we eat plants, so it's part of the cycle of life. And I'm sorry, it's far more beneficial than it is dangerous. So the reality is, if carbon dioxide falls below 150 parts per million in the atmosphere, then photosynthesis starts to stop. And when photosynthesis starts doing that, life ends. Now, because plate tectonics does trap it permanently, and I mean permanently in terms of you can take some of this carbon. Now, if it's locked up in fossil fuel deposits and whatnot, and there's other hydrocarbons around as well that have more cosmic origins. But at the end of the day, what you're trying to do, what's going on is the plate tectonics takes it down, and if it's down there long enough and under enough pressure, what we get is the carbonates. They cook and they become more like, you basically turn sandstone into marble. So that's our egg timer. Once our carbon cycle stops, no life happens, and other stuff happens as well, chemically, things that aren't happening anymore, and we're in a position away. We're far from the sun, where basically the surface of the moon without any atmosphere is 120 degrees Celsius. So if you have a look at the planet at the distance we are, if we didn't have an atmosphere, then the sunny side of the planet would be 120 degrees Celsius, and the colder side would be about minus 270 degrees Celsius. So it's a lot colder than it is hotter. So the planet loses more energy to outer space than it gains from the sun. So what can we say about, that's the Earth. Now I'll just quickly mention this. If we stopped the Earth from spinning, if you give that a bit of thought, what would happen to the oceans is the sunny side will boil off, and when it boils off, it'll set up a thicker, denser, hotter atmosphere, and so the water on the other side won't boil, won't freeze at that minus 270, but what it'll do, it'll keep the other oceans, keep those oceans water, and those oceans will just trickle back down to the sunny side as gravity does. So eventually all the oceans and all the water on the surface will just end up in the atmosphere. Now, if you take a look at Venus, our Earth will pretty much look like Venus if we stopped spinning. It's that simple, really. Now, we're just going to go from one extreme back to the middle. So we don't even need to stop Earth from spinning for that to happen. It only needs to reduce its spinning enough for that to happen. Now, you probably heard of the moon and the tidal interaction that's slowing the rotation of our planet. That's true enough. That certainly will be affecting things very slowly, 5 centimetres a year or some such thing. And we have a similar tidal, and so the moon itself, it gains a bit more potential energy, so it moves further out, and the energy where that comes from is our angular momentum from our rotation, the spins. Now, I'm just going off the cuff, so if I get lost, I'll get lost. I don't know if I'm going to edit this or not. But anyway, that's how the Earth would look like Venus, and so what we need to do with Venus to bring that back to an Earth-like planet, well, a little bit of a trick. We've got to give it a bit of love and attention. So if we sent up 20 rockets out to the Kuiper Belt and mapped the Kuiper Belt for the largest, well, for all the ice, asteroids and whatnot that are up there, if we can bring a collection of collisions with Venus, so basically head up to the Kuiper Belt, and you're going to bring some of those asteroids down into the lower orbit. Now, as we do that, basic primary school physics or high school physics, you've got potential energy further away, higher up you are from your gravity source, and then as you let it go, there you go, potential energy, kinetic energy. So by the time you bring a asteroid from the Kuiper Belt down to the orbital distance of Venus, you're going to have plenty of energy. So you don't need to thrust them out and try and make all the energy yourself with rockets. But it's not a quick process whatsoever. It's a good process because right now we've got rockets. We can go up there and do that. And it's pretty much the beginning of a very long process, because if we can bring that, hang on a sec, I'll grab a prop. What have we got? Sorry about that. That's the Earth. That's going to become Venus. Well, first we're going to pretend that this is Venus. Now, so we go up to the Kuiper Belt, bring down some asteroids, get him spinning, and what's probably not a bad idea either is to not only get it spinning, but also push it out a little way from the sun. At the moment it's sitting at 0.8 AU, so it's at 0.8 of the distance that the Earth is from the sun. So if we can end up pushing it out to 0.9 AU, then we're not going to crash into the Earth. Lovely. And it's going to be a little bit cooler, so we don't have to worry about so we don't have to get it spinning too fast. So if we didn't push it out further from the sun, then we'd probably want to have it spinning probably about once every 20 hours. So it's a lot faster. But we're not going to do that. What we're going to try and do is take Venus that's closer to the sun, hit it with some asteroids, get her spinning, and get her on a merry way outwards a little bit. And in the meantime, we're just going to be living on the Earth while she's coming out here spinning, doing a thing. The process of this, it's like anything. You can do it in 5 or 6 really big whacks, or you can send 20 rockets up there and do it in 20, increments. The very first one you do to Venus is going to be your tester. It's going to determine what you're going to do. So, because you're going to be sending in an ice asteroid into Venus, and the idea is to get it spinning and maybe push it out if you can, which you can. It's just a matter of getting the right angle of the impact, like billiards. Excuse me. Now, by the time this first one hits, the first thing that you're going to want to be studying really hard and really fast and get it right is how well that asteroid endures going through the atmosphere. It's a lot hotter, so it's going to melt a lot more. And look, in terms of what happens to that ice asteroid, guess what? You're going to end up with oceans and water and stuff like that. So the process would be, at the moment, Venus is at 0.8, not only at 0.8 AU from the sun, but it's at about 0.8 the mass of the Earth as well. So adding extra ice to this, I mean, it's almost the right amount of gravity from the start. And if we add the oceans to Venus, we'll be very, very, very close to the planet Earth, so in mass. And if we've got it out spinning, then that's what it is. So basically, instead of, I know it sounds Hollywood and stuff like that, but instead of getting super intricate on trying to, I believe Venus was looked at as got my hands in the front of the camera. Venus has been looked at as a scientists have been going, well, how can we habitat Venus? Now, the ideas that have come up that I've seen involve nothing like what I've just shown you. I'm sure, to be honest, that to me is just billiards. It's very simple, it's basic, so I can't imagine someone else hasn't come up with that idea. But applying the science to it now that we know makes it a far better option than going to Mars, which is a dead planet, spending our resources to go up and do that, and it's not going to be a long-term solution anyway. So come back to Venus, and instead of hundreds of rockets going to Mars to try and send something up, all you're doing is sending 20 rockets up into the Kuiper Belt, or have a look for some nice asteroids elsewhere, to do the job on Venus. Because what you end up with is a planet like Earth. And now, in terms of the geological timescales, it won't be a quick job. So it's going to be, it may be 100,000 years before it cools down and before we can start going, okay, well, what bacteria will live in this surface? So you go down to, the bacteria that live at our deep sea, deep ocean ridges, where the black smokers are, and you find the bacteria there and the worms, and various other things that can live in extremely volatile places. But we know it's going to be changing, because that process, chemistry, physics, it's just a matter of time. So once you get it spinning, beautiful. Once you get it out a little bit further, once you get that those dynamics right, or those variables right, then most of the chemistry will do itself. So it'll start cooling down because you've got that rotation, and once it cools down, you'll start getting plate tectonic chemistry going on. And yeah, I mean, what we already know about the Earth's history, we just apply it in sequence to the new Earth. And you go, well, what came first? And so you'd be looking at theodolites. No, stromatolites. You'd probably be looking through theodolites to see where your stromatolites are. But and so at the end of the day, it's a process. It's a long process. It might take 100,000 years, might take 1 million years. So what happens in the meantime to the Earth? Okay. Now, our orbits will be changing, obviously, because you've just made a significant change to the bodily motions between us and our node. So there are going to be some changes. Life will survive those changes. I'm sure of it. And what we have is our own egg timer, which is the biosphere, the atmosphere, the CO2, the carbon cycle of life. So all we need to do is keep this little sucker going for long enough until Venus comes up to scratch. So, I mean, look, in terms of what it needs for life, it's not that much. It's just time and patience, and let the chemistry do its job. But in the meantime, you got to survive it. And I see a lot of people scream, a lot of fearmongers throwing some weird science around, pretending that the climate change that of a couple of degrees is going to destroy everything. And mostly they're wrong, but they're not completely wrong. What it destroys, it doesn't even destroy, well, yeah, it changes the surface so that their infrastructure that they own and the systems that we are accustomed to, that we've built our societies up with, they will have to adapt, and that's all. They'll have to adapt anyway. So why they're putting so much fear-mongering into what's going on, honestly I can't tell you. Well, other than profits and the usual greed that's going on. I think I'm just about there. So we've got the Venus that's been hit by some, that we've had, we've sent down maybe 10 or 20 asteroids and got it spinning, given it some water, some nice ice to melt. And look, that could even happen faster, the cooling process, because we're using asteroids. In terms of how fast that cools down, depends on, how long we have to wait on the planet before we can start, seeding it with life. Now, there is a transition. You seed it with life, and you probably find that you're going to have to put dinosaurs and stuff on there. So what nicer place to go for a holiday than Earth 2? So we've got this one coming up onto line, so getting ready for life, and we've got the other Earth, our Earth now, that's decaying. It's going back down to, a lower energy state, chemically on the surface. So the ultimate goal is to shift home, really. So you've got this second planet over here, and you go, well, how do we get, you probably won't have everything on here to begin with that you need, but you just grab what you need and send people over, send more life over. It's, once again, we're not talking next year or 10 years time or 100 years time. We're talking geological time frames, and if we're seriously going to think ourselves to be an intelligent species, or give any credence to our ancestors and the sacrifices they've made to get us to the here and now and the technological side of things, it's worth doing, I think. If you go and do it to Mars, it's not going to last. You're always going to need to feed Mars from Earth. It's just not going to sustain itself. Whereas, you've just turned a protoplanet. All you've done is you've nudged a protoplanet and given it a bit of an extra physics in the spin, a little bit of extra chemistry from the asteroids. You got water on there. It's already got plenty of minerals similar to Earth. And by the time it does cool down, form a crust, we'll be able to get photosynthesis going there. There's plenty of CO2. There's plenty of gravity there to hold the air pressure. So it's not going to be a huge, Darwinist evolutionary step for us. Trying to get used to the gravity on there is we won't really need to, because we've evolved to the gravity on Earth, which is another problem for Mars or living on moons and smaller planets. So, how long does it take? What I'm going to say is, now we've just left the Earth and we're now living on the new Venus. So that's mission accomplished, but that's only half of it. It gets better. Because now what you've got is an Earth that's just getting colder and older. And one thing we haven't talked about yet is the moon. That's a fun one. So the idea is, now what we've got is we've just brought Venus back from the sun a little bit, given it some spin, let it become an Earth, and then moved our life onto there. And now this is starting to, decharge basically. So now the trick is to bring our Earth into where Venus was. Now, why do that? All right, we're going to do the complete opposite. We're going to do the reverse. This is going to be like exchanging a battery. So exchanging planets. So we take Venus, bring it back here, get that turning into Earth at 0.9 AU. And by the time it's turned into Earth, our Earth is pretty well given up the ghost. Its surface chemistry is pretty well cooked. And so what we can do then is we go bring the Earth down into the Venus orbit, and we also have to stop the Earth from spinning. Now, why do we do that? The reason why we do that is because we want to turn it into Venus. Why would we waste our time turning it into Venus? Well, it's pretty simple. I know you've already come a really long way. It's already a big, fantastic sort of journey. But no, we need to get the Earth in there and basically turn it into Venus without much spin whatsoever. And the reason why we do that is because it will burn off all the oceans. Burn it off. It'll boil off the oceans and create that big nasty atmosphere that we're talking about. And on one side it's going to be getting cooked, and on the other side it's not going to be getting cooked. It's exactly the same as what Venus is going on now. But the chemistry of this new Earth will have water already in it. And that water will vaporize off into the atmosphere, make a big atmosphere, and plenty of CO2 and all that sort of stuff will be coming out. And we're still at a distance where the sun, now on one side, heats up this planet on one side. Sorry, my hands are... heats up this planet on one side, and there's such enough atmosphere to stop it losing more energy to space than what it's gaining from the sun. So basically what that does, it's recharging the planet Earth while we're using Venus. And that's pretty much the complete cycle. So what we end up with, we're living on what was Venus, with Earth down there now. Venus is now spinning. It's got everything going on. It's life. It's Earth. We don't have to worry about anyone else. It's self-sufficient now. There will be obviously there's going to be some slight differences, but we're going to be ready for it because we already know the geology of our planet. So we know what to expect. Now, this is basically a battery change. So, in about another million or so years, after you've been mucking around on here, it could be 500,000, I'm getting my numbers up. Probably look at 1 billion years you'll have of life on here. So from your when you chuck your little stromatolites down, they can turn all the minerals into whatnot and suck the CO2 out of the atmosphere, turn some of that into oxygen, then we get the great oxygenation periods, and there's lots of chemistry that can go on, and it'll take a long time. Like that's for real. And that doesn't matter. The whole point of eternal life is a long time. So It'll take a long time to do, but it'll give us an awful lot longer of surviving in this solar system. So, in 1 billion years of life, maybe 2, the old Earth has been collecting, heating up the system, heating up the rocks, and you know, that's the lovely part, is because now it's all coming back into the one system. All the elements, are they recharging? I don't know. I don't know what marble will do. It's certainly going to melt and release that carbon in some form of igneous rock or igneous rock. I can't remember that particular word. So it's going to be molten again, mostly. Not all of it. I mean, it's science. It's not maths. You don't get a pristine result every time in the real world. So you've got to deal with it. Now, let's say it's 1 billion years, you swap it out, bang, bang, recharge, bang. So you get that now. I know it sounds far-fetched. And we can keep doing that until our sun itself has its own cycle. Now, I think what we'll find overall is our sun is decreasing. It's losing energy through the light. It's not gaining an awful lot of mass from anywhere. So, and this was one of the major problems that started bringing in the concept that fusion was going on in the stars. So it's got a lot of energy now, but it's not always going to. It's putting out an awful lot of energy in light. Excuse me for a sec. Oh, nice. So it's putting out a lot of energy and light, and it will run out one day. But in the meantime, woohoo! Long process, and I know it sounds far-fetched, but that's only because we only live like 100 years, 80 years, 50 years. We're short-lived critters. And until you start looking, until you start seeing the universe, planets in geological timescales, and then the universe in cosmic timescales, it's not going to make much sense. But that's what you have to do. By the time, for the amount of time that this is done, now in terms of keeping our planet going a little bit longer, we can do that too. We can't do it forever because that cycle is what it is. And we will be losing our chemistry, we'll be losing our carbon. There's nothing we can do about that, really. Not on a scale that's going to be permanent, and we can't really heat up the planet unless we stop it from spinning and let the chemistry look after it. Take it in closer to the sun, do the swap around. That's about the only way we're going to bring the Earth back to life or recharge it. But as you know, Venus, we can't live on Venus right now. So we're going to have to go and charge it, go up into the Kuiper Belt, grab some asteroids, play some cosmic ping pong or cosmic billiards, that's better. Get it spinning, get it going to where we want it, whether it takes, 10 big ones or 20 little ones. Just a word of caution, I'd probably go the smaller ones if we can, because it'd be a lot safer. If you just go up there and go, oh, there's one the size of the moon, how about we just use that? It's got everything, we only need to do it once, you beauty. you know, lovely, nice, yep, good to have confidence, but you know, one big moon crashing into Venus is a hot plodge of mass. It is a rocky planet, but it's hot, much hotter than us, and so its crust is a little bit thinner. And if you start throwing rocks at it, if you throw one big rock at it, you'll probably cause some splashback. And if you get the splashback going, you're just going to make a mess of the whole thing. It'll still work, but you're just going to make a mess. And you know, we're not far enough away from Venus to not cop any of that mess. And so while we're still on Earth, you don't want to be causing unwarranted dangers. So if you get 20 rockets, 20 reasonable sized pebbles, not too big, not too small, do your first test, bang, see how we go. Each time, the first one that you go in might only just start turning it a tiny bit. That's all right. If there was no splashback and it was safe, beautiful. The second one might give it a little bit more. Third, fourth, and fifth. And by the time you've got, 20 little rocks that you've crashed into it, you'll have, if you think about what's going to happen to the planet in terms of its mass, in terms of how much water we've got on our planet, it wouldn't hurt to get, 20% of the mass on the surface. Mind you, it'd be a bit floody, but anyway. But that's the point, is you're going to be bringing down some more mass, and that'll be in the form of water. And it just makes sense that, billion years, you wait 100,000 years, maybe 10,000 years. If it's all ice blocks, like I say, you chucking ice blocks at it, it's going to cool down an awful lot faster. The first few are going to sizzle off, but that's all right. Nothing wrong with a bit of a sizzly ice block. So, in effect, you've got that rock and rolling. By the time the Earth has come down and is now in a Venus position, its oceans are boiled. It's got a bigger, thicker atmosphere. It's keeping in the heat. The surface crust is absorbing that heat. I think the hot side of Venus is like 500 degrees Celsius. So, we've certainly got a better transfer of energy going through when it's not spinning. Now, in terms of what happens to the planet, to Venus at that time, to the Earth or to the planet in the Venus position, the oceans boil off, become the atmosphere, and the sun on the sunny side, that does some extra chemistry to all the atmospheric stuff as well. Starts breaking down molecules, adding energy to them as well, but breaking them down. And so I believe Venus has no water molecules in its, not very much water molecule in its atmospheres. So it may do. I haven't checked. I should ask that. Yeah, have a look, see what they've seen. But certainly not enough to form big oceans. Maybe not enough to form big oceans. I'll have to look at that as well. Yeah. Anyway, we're going to be bringing down some asteroids full of ice. Another part of that is asteroid selection. By the time we start this project, we might want to consider what elements we use, the elements that we use, how we use them, and what's finite about them, because they are finite. We do have some on here that we use that are very finite, and we're not going to gain them back. And it's unlikely I mean, for example, if you take helium, if you take helium, for example, and release that into the air, it goes up into the air, and then it goes out to space. It leaves the planet forever, so it's finite, and it's a non-renewable resource, but it's a very handy stuff to have. So in part of that whole process as well, you're looking at, I mean, I don't know, by this stage you'll probably be able to get plenty of helium off the moon's surface and stuff like that, because there's a little bit trapped up there. But you really, when you're doing the Earth swap to Venus, taking people and life and whatnot, you also want to take a nice little duffel bag full of minerals that you know damn well in our system are not going to return to planets. And if they're handy, like helium, absolutely. I mean, you want to be able to go to another planet, breathe it in, and speak like a squeaky squeaker. All right, I'm going to leave it there. That's been a long bit of chin wag. And I think that's covered most of it, just swapping the planets out. And talking about why Mars it's already dead, and the amount of energy that you need. I mean, I was looking at their experiments, and they're talking, if you add it up over the time, it's like 20,000 rockets. And that's by the time the Earth dies. And then when the Earth dies and you're on Mars dies because it's just not sustainable. The two main factors, do you remember what they are? It's too small, too tiny, and it's too far out the back, too far away from the sun, so you're not going to get a productive level of photosynthesis that we can get down here, and doing this process. So basically, you're going to end up with a new planet, new Earth. And then you're going to take the old Earth and you're going to put it down into a recharge position closer to the sun. Now, if we're clever enough to be able to do that, and it doesn't take much, honestly, we've already got all the technology and stuff. You just got to have the patience. And the trickiest thing will be is perpetuating that knowledge from generation to generation to generation. Because as you already know, we've had periods like the Dark Ages. We've also had periods of like Enlightened Ages where our ancestors were pretty clever little ancestors. They had some pretty cool tricks. They were very accurate about the stars. Now, they were a lot more accurate about the stars and had a lot more knowledge about what was going on than what the Western world was delivering for about a couple of thousand years, and that just came down to politics, religion, and the reality is you have to preserve the knowledge. Now, I know that this is one of the things that humanity has a real hard time with. We've got some really cool things. We've got writing and bits and bobs. One of the realities of planet living is it does recycle and renew. Not only that, we've also got, even today, we've got a group of people with an ideology whose law involves a tradition of destroying the world, keeping a few survivors, and then rebuilding the world, build back better. Now, you've probably heard build back better recently. You've also probably heard terms like the Great Reset. Now, in the mainstream circle of things, you'll know that that's being touted as a conspiracy theory, and you know, every now and then you'll bump into someone. I just bumped into someone today, actually, who was talking about, you know, he doesn't believe in the conspiracy theories of the Great Reset and the New World Order and stuff. And that's all cool. Like, the mainstream media does, it avoids telling us lots of stuff. I think most of you are pretty okay with that. So when it comes down to the New World Order, Great Resets, and recycling the surface of the planet, and you know the eugenics arguments. You look at Bill Gates, and you know, is he injecting things into people? And well, he is. And what the ideology is behind it, it's not a secret when you see him speaking it, and you just go, okay, yep, no, well, that's his gig. The Great Reset, when people look at you like that's a conspiracy theory, you just show them the book written by Klaus Schwab, and that he's the CEO of the World Economic Forum, who has, well, I mean, you probably know more about him than me, but from what I've seen, when he started the World Economic Forum in 1971, the whole idea was to see, he came from a background of the Third Reich or something like that. I don't know those details in particularly, but he did come up through a background of engineering and very strict Lutheran stuff and whatnot. You know, the nice way to say it is trying to solve the population pressures of the world, and that includes eugenics programs. It is a global issue, and you're talking about people with souls, talking about people with families, with children, with hopes and dreams for a future. And what we have today is a group of people who they've hidden the discussions as best they can, because it's an awkward discussion to talk about. And instead of offering the discussion to the public, to the people, and we certainly have the technology to do that, the communications, instead of doing that, they've decided to go behind closed doors and start planning the future ahead to reduce population. So anyway, that's my poolside chat. That's an hour. If that didn't put you to sleep, so maybe some of my music will. So find another. Oh yeah, look, I've got my piano shirt on. Look, that's what I used to be. Piano man in the outback, just singing songs because I was a piano man, and playing bars and whatnot. So I've got a couple of musical bits and bobs. Movies, a couple of animations. They're fun because they just explore a bit of the physics of stuff and the maths as well. So even though I've just been presenting a super simple kind of remedy to how to extend life without going through all the maths and chemistry and physics of it, it's real, it works. Run it pen to paper and you go, oh, yeah, shit. It's going to cost us next to nothing compared to trying to revive the old corpse of Mars, and any of the other projects we've got. So 20 rockets, guys. 20 rockets and just a couple of little extra doodads. Of course, there's always more to it than just that, but that's the simple side of it. Geez, look at that. Time flies when you're flapping your gums. Alright, well, I think that's it. That's it for the Venus. I'll just title this Venus. Now, I'm not going to ask you for a tip. I'm just going to leave a PayPal thing somewhere. If you see one of those PayPal / murryrhodes, $5, cup of coffee, that'd be lovely. Takes a lot of cups of coffee to come up with all this stuff and sit down and do the research and make sure this one's not there. And, oh, what's that? Yeah, no, that's... So it does take a fair bit of time. And like I say, I won't ask you for a tip, but, I'll leave that in your ballpark, and that'll be great. Means a lot, actually. Right here. And engage. Leave comments. I mean, if I can, I'll get back to you. And, the world's too bloody short to not engage with it. That's why you'll also see some of my nature videos, run around like a Rambo with my camera, and catch some really nice, some beautiful stills of birds and butterflies and pretty much whatever is going on. Yeah, because we've got all sorts of things that we do up here. Got nature clubs that go out and help repair old ecosystems. Because it is one of the things, like, I know all that gas bagging about Venus and stuff. It's out of this world stuff. But at the end of the day, and I think most people agree, the universe is a far nicer place with life in it than if it just dies. And one of the things that we have is, I remember in the Bible, because I'm not religious, you'll see I'm starting to use the old books as law references for what's going on in the world. But one of the things that sort of I used to be really uncomfortable about hearing about one of the religions or any of the religions, and they'd say, "Oh, that baby is born with sin." It was actually one of the biggest turn-offs. I'm like, what? What kind of people are you who think an innocent child can possibly have any sins and have done anything bad that deserves to be raptured and captured and punished? Because that's normally what you consider sins are, is something to be, you need to be punished. You need to pay your debt to society. And I said pay your debt to society for a reason, because the more you look into words, where they come from, how they come about, and then why things get said and how things get confused. Debt to society. We're talking about life and perpetuating it, the life eternal, and so we can go on from this planet to the next planet. And we've got a nice warm fire, nice sun up there. It's going to last a few billion years. So if we can get 2 or 3 of these exchanges done successfully, then we've done really well. By the time our sun is actually properly in its own cycle of the end, we do need to get out of the solar system. And we do have ways of doing that too. We've also got the technology today if we want to do that. I haven't published anything yet, but if the world settles down, I'll publish some stuff that'll make some sense. More practical stuff than wormholes and things like that. If there's better options around, by all means use them. But they're reasonable, practical solutions, so they are what they are. But in terms of what we owe and why do all this, why go to all this sort of trouble, and in terms of religion and calling babies being sinners and whatnot, one of the things is, when you're born because your mum and dad had a mum and dad who 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 had a mum and dad. You get the picture. So great. Now, I think by the time I don't know how old you are when you start to realise the true value of your parents and the sacrifice that they make. Now, of course, everyone's story is a little bit different, but in general, and for the most part, your mum and dad make sacrifices so you can be here, and their mums and dads made sacrifices so they could be there, and it just continues to go backwards and backwards and backwards. So realistically, when it comes to a sinful baby, back in the ancient times of Rome, the word sin quite literally meant rent. So house rent. You pay your rent for you to stay in the house. So that was a sin. Now, in terms of a baby being burdened with a debt, it's not a crime, it's not a bad thing. What it is, it's just, you kind of owe it to your grandparents, you owe it to your mum and dad, you owe it to your grandparents, you owe it to their grandparents and their grandparents, and your ancestors. People that aren't with us now, but who have all, if they didn't do what they did, you wouldn't be here. And it's that simple, really. So in terms of our debt, we really want to pay that back to everyone. And like, if you could imagine summing up all the tears, all the pain, all the blisters from doing work, all the wonderful creative ideas that you've done. Oh, let's rub these two sticks together. That'll be good. Make some fire. Bingo. All of those things. Everything that our ancestors did for you. And for me. For Joe Blow driving the car. Oh, that's Dimmy. There you go. So yeah, I'm going to close that down. I'll probably mention it again if you want to pay. I won't mention anything about I won't be asking you to pay a tip, but if you do, love you. That'll be great, because it certainly hits you in the old thank you, and helps pay the bills. Keeps paying the rent, pays the sins. So yeah, look for some new movies, look for some other movies. I think this is the longest chin wag I've done ever. I don't mind it. I've been trying to do the short ones and keep them under 10 minutes, but each time I get to 10 minutes, I'm like, oh, have I said enough? Have I said too much? and just bagging for an hour, it means you can just hit play, let it go. Now, I'll tell you just quickly, some of the other movies I'm doing are animations. They're not a normal format of movie, they're like an information animation. So what they are, they've got lots of pages of writing, that scroll in and blink and out. They've also got some just little hand-drawn animations, like you do at school. Just a bit of fun to try and tell the story that's going on with the words. But I'll just warn you now, is when you start watching them, you're probably going to want to hit pause to read, but don't. The best way to get the most out of it is, sure, read what you can. There'll be a headline saying, oh, pyramids do this, and then there'll be and you'll probably get to 3 or 4 sentences, and there's still going to be a couple of paragraphs left. Over there's a animation going on, and then it'll move on. So you right, don't get, watch the whole thing first. So you'll see the animations, you'll see the headlines, and you go, oh yeah, okay, nice, and that's how it kind of flows a little bit. And you'll get the gist of that. And so you'll see a few headlines that you might want to come back to. But for the first time you watch it, just watch them straight through. The animations are kind of a little bit fun, but also a little bit informative too. It's just my way of being able to say 1,000 words in a little animation. So I may even do one of this because it's right in the ballpark, but I haven't done one of planet swapping yet. If I get enough, folks interested in looking at a planet swapping animation, I'll do a planet swapping animation. But in the meantime, I've got a couple on. I think I've done one on pyramids. Now, I haven't used the details too much from the pyramids of Egypt or anywhere. It's just a 4-based pyramid, looking at the physics of the shape, and then incorporating it as if it was the hull of a spaceship. Of course, if you've got 6 of these together, you can make a cube. Beautiful. Just fits together, becomes a cube, and that way you've got 6 ships. It's just about space management, time management, and also there's some nuclear thrusting devices that I throw in there as well. Just some physics, and it's just drawn nicely. So it's not. Some of the words will probably be a bit big for a few people, but most of it's just drawn nice and simply as I can. And it might take a couple of watches for it to all sort of, for the penny to drop. And some of them will be more simpler than others. Some will be just out of this world. I do one on the spirit of, on the forces within our atoms that can be determined as our spirits, memories, the creative part of the brain, and of course your souls, which is very important, I think, and that's the part of the universe that keeps us the loving, compassionate human critters we can be when we're not being wallies, warring and doing nasty things to each other. So it's going to be a balance, and that's that's the main reason why I don't run around bloody publishing ideas and innovations, not yet, because there are some energy solutions for the planet that help prolong the planet's life, and I haven't seen any publications of my innovations, so they're probably new, and I won't do that until I'm certain that there's not going to be just an angry, nasty global government running the world in like some gulag, concentration camp, where every culture that's ever been gets fused into the one nothingness. So I'm all for preserving cultures, preserving the legacies of every culture that ever was, your granddads. As far as I'm concerned, there's a whole parliament of our ancestors watching us, in our conscience. That's where it should be. And that comes through on the atomic scale of memory and things like that. So, when you see animals in nature doing very complex things that they may not have been taught to do, it just comes down to, we do the best we can with what we have. And we're not all dummies. You asked the question of if humans would walk if they weren't taught to walk. How long would it take a child to walk if it didn't even know that walking existed? How long would it take humanity to discover fire if they didn't know fire existed? You know, when the English, I think when the British explorers were going out, they were recording a lot of tribes, a lot of peoples that didn't have fire. They either didn't have the technology or they just never saw fire. Some islanders that never saw fire, and that story had never been passed down from someone who might have seen fire, which is, you know, we touched on the importance of preserving the education side of it. If you do this, could you imagine if let's say in the next 50 years we've sent up 20 rockets, brought down 20 asteroids, and given Venus a fling, and it's now sitting at 0.9 AU. Can you imagine then if something happened to the surface of our planet that just wiped us all out? Well, you know, wiped out most of us, and no one knew what was going on with this planet. And then eventually, you know, we come back and the knowledge is lost. I'm pretty certain we'd look up and still see this planet, because it'd be a lot bigger, and you go, oh, okay, yeah, cool, nice. What's that? Can we chuck a rock at it? Can we spear it? Can we eat it? And if they don't know that it's ready, it's a planet that's ready for us, then they're not going to know. So, if you like to think about history, where we come from, and how it happens, you'll see there's quite a few folks out there who are trying to put together enough evidence to show that we had ancient civilizations that disappeared. Now that's true even in the archaeological record. We've got various things going on, and even in the Bible we've got biblical records and accounts of different things that are going on the surface. And you know, there is a train of thought where we could have been aliens. I think you'll really like my pyramid exploration. It's an animation. In terms of did we come from a mob of aliens? And you go, well, maybe we've already been doing this. So the reason why we've got a equal sized planet, 20% closer to the sun, is not an accident, because this particular process it's a natural process. It is the most obvious way of prolonging life, by bringing out a new planet, a protoplanet. We already know about protoplanets, and the Earth was once a protoplanet, and something happened to it. Some of the physics attributes of it brought it into being, you know, what it is today, a habitable planet. So I'm not saying for certain that there's aliens that have set up this type of scenario with a perfectly sized planet. Oh, look, looks like I've got my head. Oh, there's my brain, look at that. So I'm not saying that that's what it is. I'm saying that's a very close, what happens when we start adding water to this Venus up close, get it spinning with some asteroids, and its waters melt. We've now got a planet almost exactly the same mass as the Earth. And so our evolutionary path, we're a very complex little critter, and complexity is I know Darwinists like to go, 5 billion or, a billion years, that's enough for X amount of generations, and it's all down to chance, and, is it chance? And you go, all right, yep, no, because I like the Darwin origins of species. I can see that process. I see that process happen all the time where, in our society, there are people who collect beautiful birds, and they breed beautiful birds, and they make money out of selling beautiful birds. So it's in their best interests if all of their beautiful birds live. Even if they have a deformed leg, even if they wouldn't be able to survive in nature, they're still a beautiful bird. And so, and they still have a financial value to the owner or the breeder of that bird. So what you get is some of those birds that may have a slightly deformed beak or a slightly this or a slightly that, they'll be bred again, and that trait or that error may or may not get passed on through the gene pool. So now you have, in our society, we're able to create a gene pool of people who are not the strongest natural critters. But when you're out in nature, you do see animals helping other animals as best they can, but you very rarely see crippled animals surviving. Yeah, you'll see a seagull minus a leg or something, but if it was a seagull minus a wing, then it'll probably get eaten by other seagulls or pelicans or whatnot, because it can't get out of the way fast enough like the others. That's just nature, and it's the dark side of nature, but it's also the side of nature that it makes not necessarily the origin of species, but it certainly makes a species far more adapted to nature, because the stuff that doesn't exist is not there. The stuff that doesn't exist is not there. The stuff that's not fully adapted to nature doesn't get to live. So if you think about that for a second, and you go, us as a species in space, if we're adapted to our nature, and if we're going to survive the universe, we kind of want humans have always been about making changes to its environment or extracting resources from its environment and being creative. And that's how we've progressed. That's how we progressed from being very low on the biological food chain to we're still actually very low on the food chain. There's crocodiles just over there, and plenty of them. So if you go up into there, you know just how weak and pathetic we really are, in terms of a single critter in the bush. We get sick quite easy. We die quite easy. But because we have behaviours, because we have tools, because of what we've done with our environment, and we've done it to a certain point where there are extremes. We're making a mess of the place, and that's no good. That's really not. We're even endangering our future by trying to put nuclear bloody energy systems around, and there's better solutions to Earth's energy than that. I know it doesn't seem that way yet, but that's what some of my little innovations might help with. And it won't be nuclear, it won't be anything that's dangerous, and certainly won't be anything that's not manageable for the planet. In fact, if you use it, the longer you use it, you're going to be getting bulk energy out of the process. But the longer you use it, you're actually helping the planet last longer. And if you maintain the system properly for its efficiency, most efficient use of it, then that's precisely what's going to happen. It helps prolong this planet. It helps prolong the surface chemistry of the planet. So it even, while we're waiting for Venus to cool down, if we've got the system operating on here, if it takes 150,000 years for Venus before, or let's say it takes 1 million years before Venus is good enough for us to go, righto guys, we're going to call it quits on the Earth, going to go over to Venus, and you do need a power source that's going to last that time, and we do have that source. We just don't know it. And like I say, it's the type of thing that I wouldn't be prepared to put in the hands of a group of people whose only goal is efficiency. Because life isn't all just about efficiency. Life is also about the textures, the emotions, the people, especially the people. And I know some people, haters, might say, no, fuck the people, excuse the French. But look, we're the only ones on this planet who can actually do stuff like this. And there's other critters and species on here that you love, even if you don't love people, that need to get from here to there. They're not going to do it themselves. So whether you hate us or love us, that's a reality you have to face for yourself. Personally, I love us. I love everything. Especially if you get to see the animation on the soul, on how atoms work and the quantum electric fields, but also the gravitational fields. There's a lot of stuff to offer in physics and to try to understand it, where even the spiritual stuff that you have in your mind that goes out and comes back, it makes sense. You can make sense of it in physics. The reason why we have thoughts, why we have memories, it's lovely. How we can join dots. The little workshop of the noggin. Bounce a ball, catch it, or fumble. Make an observation of an ant and go, well, that's a behaviour. There's a lot of stuff, and it's not only us, it's this conscious sentience. I grew up as a kid with dogs and animals and all sorts of things, and damn well you didn't need a science paper to tell you that your dogs understood you, or cats understood you, and even if you put that into a category of repetition, rote and learning, well, guess what we do? Reward. 1 + 1 is 1. Or 1 × 1 is 2. And I do appreciate that that we can say and look and think of a lot of things that are and aren't true and replicable, but that's true. And so is the possibility that this is not our first time through either. So when you talk about aliens, I got to tell you, going from one solar system to another is not fun. It's not practical, and I don't mean it's just not fun for us to live and whatnot, and so you need to get hooked up to a machine or anything like that. Go to sleep for 1,000,000 years until you get from one system to another. Sure, I love it. Go through a wormhole so you don't have to wait so long. Yeah, great. But the reality is all the materials that we know of, they just don't last. So what you're going to get is an exodus very similar to like what you see on Battlestar Galactica, and it's going to be much longer. It's going to be over generations of generations of generations, because there are no jump drives. I'm sorry, like, I hope there is one day. What I honestly do, and if you can show me that that's bang to bang to bang, there, beautiful. Send me an orange via wherever. No worries. Quite happy to go, yep, beautiful. Muzzle was wrong. Wormholes are real. Relativity is... Anyway. While we don't have that technology, until we do, we have to prepare for things if we don't, if we never have it. Why would you not? It's suicide if you don't. It's like going, oh, there's a fire coming. It's gonna take out the whole village. I tell you what. Don't go out and use those buckets. Wait until I finish inventing the fire extinguisher, and then the fire extinguisher will be made, and it'll be able to put the fire out. Now, if the town said, yeah, no worries, you're an intelligent scientist, we'll let you build while the fire's coming, we'll let you invent a fire extinguisher that is magical at this stage and doesn't exist, and just let our town burn without grabbing buckets and doing the best we can with what we've got. So I know I did a post on X a while ago, and I got oh, don't you want money for like CERN and all those really big projects that take shitloads of resources out of the system and return little more than a few jobs, but most of the time it's just money going into someone's pocket, and it's usually the same sort of certain person, people or institutes, and that's just the reality of it. A lot of the science that you've come to know in school is good, but there's also elements of influence that have happened throughout history, and for different reasons. It's usually to do with power and money. And considering this was only meant to be 10 minutes long, I should probably try to wrap it up there. Earth, beautiful spot. Go fishing, go look at the birds. Nice, look at that. And this is probably a nice little sleep video too, because I've got the sprinklers going on there. I've got the crickets over there, so they go. I'll probably fall asleep to this one day. That'd be good. And it's long enough, so you can just press play. I'll make sure I switch the ads off. And because I'm not doing any ads. Oh, would you like to buy an ad? There you go. So yeah, there's the PayPal tip jar there. I won't ask you to pay any tips. but I'll leave that in your ball court. Leave that karma ball in your ball court. Be lovely to get some, you know, get some refillers there. Good for the old house. And look, there's some other stuff going on as well, because I do the nuclear bits and bobs. And you may have seen my letter to the world's leaders, informing them of the recent environmental change in our use of lithium and its own little nuclear properties and whatnot. Anyway, look, I mean, when you start playing around with space, the space machines and space thrusters, you're dealing with all sorts of energy. And, you know, this is why you come across some new questions of what would that do in case of X, Y, or Z? And when you do research it and you find out that there's no information on it, you go, well, why hasn't that been tested? You'll always find the answer to that too. Anyway, guys, take care, be good. Life's a great, big, beautiful cycle, and if we're on this cycle, Venus, Earthy, send Earth to Venus, recharge. It's like pulling a battery out. Go, oh yeah, battery in, charge that up while we're, you know, bonking away on this Venus planet of love. And then once we're done on Venus, in a million, billion years' time, we pull that one out. Yeah, just do the same. Beautiful. Swap it out, charge batteries, charge planets. And, you know, by the time you figure out how many solar systems have two almost identical mass planets within the Goldilocks zone, you might even ask yourself, well, what are the odds of that happening without other interventions? So if you want to be a really successful space species and just have a plan, Stan, a few tools in your belt, don't try and set tents up on dead planets and dead rocks and pretend that you're going to be able to bring it back to life. Otherwise, that's an end journey. That's an end game. As much as doing nothing. So here we are right now. You can imagine that's our planet. It even looks like it's got Australia on it. If you imagine that's our planet and we are right here, right now, and we don't have, you know, people like Elon Musk. Let's pretend his biggest thing was he was, you know, comparing yachts to yachts and mansions to mansions. I mean, he's a special bloke who, you know, he likes space. Sure, he's selling rockets and he's selling the dream of Mars to sell more rockets. But there is a reality check as well. It's doable. And if you sort of move away from the idea of going to Mars and spending all your energy trying to send it up there, and you just use what you've got in your solar system, you know you've got a nice big belt of, you know, we haven't even mapped it properly. It's just a Kuiper belt of, a big belt of debris. There's a few of them. You know, there's been a few planet forming processes going on, so you do get debris belts across the way, and so go up there, map them, send up 20 rockets, crash them into Venus in the right way, get it spinning, lovely, let it do its chemistry thing for whatever. And in the meantime, we just sit back and look after this planet. We look after this planet and make sure our education doesn't get lost. Make sure our messages what we're up to doesn't get lost. You got to find out the right way of doing that. And, you know, the best way is to create a language that we all understand. Create a language that, if we've never seen a language before, and we see this book or something, a rock, hand painting on a rock, saying, "G'day, future, how are you?" If you can figure out a way to get all of this information into a rock painting, or into an engraving, or into a language that you can slowly get people to learn if they come across it. Language is not easy to, if you don't know, if you don't have the curses, it's just a bit of flip-flab. It's pretty pictures. And it takes a lot of work to try and get that out, to try and figure out different languages if you don't have any thing to go on. So you want to make that as simple as possible. I mean, I like the Roman numerals. I like the Roman numerals and the Roman lettering system, because it's just plain and simple. I think the early ones from Mycenae, or the cuneiform and stuff like that, which kind of looks like really basic Chinese, where it's just a couple of bits and bobs. Of course, Chinese, that kanji just went into a slightly different ideology of forming shapes and trying to replicate them using little dots and squiggly bits. But yeah, look, go and have a look. If you don't speak or write Chinese, go and have a look at some Chinese stuff. Or even if this is being translated into Chinese, and you're a Chinese person who's never read English or whatever, or another language, just find another language that you don't know anything about, and see if you could understand anything just from the scribbles. You can't. I mean, really. You need pictures, you need art, you need communication. Unless, of course, you have the technology to store it somewhere in the genetic code. So if someone is alive at some stage, it might just manifest itself into a sort of matrixy kind of shape and come out as information. We're pretty complex little critters. Just the message from the brain to move the finger is, that's pretty complex. But it's a memory. I can even do it with my eyes shut. Look at that. Eyes shut, eyes open. Anyway, it's been fun, guys. The sun's going down. It's just been a really long poolside chat. And yeah, there's lots going on, lots of life everywhere. Flies, birds, more birds, crickets. Yeah, it's lovely. So the sun's about to go down. It's been a nice afternoon in the pool, just chatting with you guys. Nice. Nice. Take care, guys. I know that was a super long one. Maybe you've just put this on as your sleeper video, so you play it every night. Probably not. But yeah, so if you do, you'll probably, some of that penny might just drop, and you go, oh, yeah, nice. We got somewhere to go. Let's all get off our asses. There's a lot of work in doing that, actually. Like, I know I send 20 rockets up. Of course, none of us are rocket builders. we might be able to make the coffee for the person who drives the bus, who takes the people to the rockets. There you go. That's part of society. That helps. But yeah, so it's just more a matter of taxes, what sort of projects we want. As far as the nuclear project goes, and the letters that I've been sending off to the leaders of the world, going, yeah, nuclear arms race is dead in the water. We're better off using the money for more productive projects. And of course, the intent is to use whatever we use for war, not on war, but helping people on the planet live nicer lives. And if we've got some spare change, we do need to get onto that pretty soon. I know some religions are like, they want to do the eugenics, cleanse the world type thing and restart their cycle again. I think this is the 7th one, according to their Bible. I can't remember what part of it was, but in the Old Testament, they have their 7,000-year cycles where it's 6,000 years of go forth and multiply, and then 1,000 years they just kill off everyone, take a day off, and I think it's a 1,000-year Sabbath or something. But look, there's all sorts of translations and whatnot. So that's about it, guys. From that perspective, I'm there. Yeah. Interesting. Anyway, sun's going down. I don't know where the moon is at the moment. It'll be up there somewhere. Or down there. Alright, I think that's me. Take care, guys. That's been a really long chat. 1 hour and 40 minutes. Look out. I'll never get to see this again. But thanks for watching. If you got this far, you guys are legends, absolutely. And you bet your bottom dollar that's the best way to do it. Going to Mars and stuff. I appreciate the sentiment. This one doesn't sell lots of rockets. This just saves life. Going to Mars, that sells lots of rockets. So, you know who someone is and what their motives are by what they do, by what actions they do. And mine are just completely bananas. But yeah, so anyway, hopefully the nuclear arms race can be just shut down, like the amount of stuff we've got going on. There's never been a better reason to stop nukes, to be honest, with all the lithium going on around the world, and its nuclear properties. I mean, you just don't need them. You don't need... One nuke can destroy the planet. And that's never been that way before. But before we didn't have all the lithium batteries. It's like putting fuel on the fire, in case you didn't know, lithium is part of the nuclear bomb making process. And it's its own nuclear fuel. So, which doesn't change anything for you or I, because you or I are not going to be in safety bunkers. But a lot of people have spent billions of dollars building big bunkers and stocking them with enough to, live 20, maybe 10, 20 years. And with the advent of the lithium, that changes all that. They're no longer built to code because the lithium will make a bigger explosion. And not only that, is the radiation fallout is far longer than the nuclear winters, and the radiation fallout is far longer than what any of them will be stocked up for. So fingers crossed they take that on board as a bit of wisdom and go, you know what, guys, having 60,000 nuclear head missiles pointed at everyone doesn't need to happen, because we only need one in the right spot. So all those other rockets, guess where we can send them? Yeah, go up and grab some ice rocks from the Kuiper Belt. Probably can't. They're going to need some. But you know what I mean. The amount of money going into that, and just go up and save the bloody people, not just profits. Anyway, if you haven't seen me before, I'm Muzzer. There you go. Murryrhodes. And if you've gotten this far into the video, you're an absolute legend. And yeah, I hope you enjoy. I hope everyone has a nice life. I've been sending letters off to the leaders, not only of the world for the Duke stuff, but also for the smaller skirmishes, just the nasty, ugly ones. I'm sure you know which ones I'm talking about. And writing to the leaders and just throwing a bit of Muzz wisdom at them. Bit of Muzdom. Oh, look out. Yeah, there you go. Anyway, I'll leave you with that Muzdom for now. That's 1.5. Oh, yeah, that's almost 2 hours. That's good for the throat. Might be able to sing one day. All right, ta-da, good night. Be good, have fun.